Here we have Lucas taking a free throw.
Let's watch that again and break down how the whole body is used for the shot. To execute a good free throw, it all starts here in the legs. A bending at the femorotibial joint allows the shooter to generate a lot more power for the shot. As the athlete prepares to shoot, he slightly crouches down. The hamstring muscles, which consist of the bicep femoris, semitendinosus, and the semimembranosus, contract concentrically, which leads to hip extension and knee flexion. Another muscle that assists in knee flexion is the gracilis. Anterior to the hamstring muscles, we have the anterior thigh region of muscles, which is commonly known as the quadriceps. The quadricep muscles consist of the rectus femoris, vastus lateralis, vastus medialis, and the vastus intermedius, which contract eccentrically, performing the action knee extension. Therefore, this movement is a co-activation of the hamstring and quadricep muscles. As we look inferior to the thigh muscles, we have the posterior leg muscles, which contract concentrically as the player performs a calf raising motion just as he's about to shoot. The main muscles used here are the gastrocnemius and the soleus, which perform ankle plantar flexion. Lateral to these muscles, we have the lateral compartment of the leg, which consists of the fibularis longus and the fibularis brevis, which also contract concentrically during ankle plantar flexion. Throughout this action, the talocrural joint, which is a synovial hinge joint, is assisting in plantar flexion. Inferior to the leg muscles, we have the plantar foot muscles that are contracting and are stabilizing the athlete's body. All these muscle movements and contractions end up creating the torque that will allow the legs to snap back to the starting position, which will generate the power to get off a good shot. This is all happening in the sagittal plane and along the coronal axis.
We then move up to the trunk. The abdominals are engaging to keep the body straight and start guiding the direction of the shot. Let's break down the specific muscles involved in the trunk's contraction phases. The anterior lateral region muscles help generate this needed trunk flexion. The most superficial part of this region is the rectus abdominis. The rectus abdominis is the largest muscle in this region, which helps generate the optimal amount of force. As we go deeper and laterally into this trunk region, the internal and external obliques and the transverse abdominis all assist in trunk flexion and are all contracting concentrically during this stage of the free throw. This is happening in the sagittal plane along the frontal coronal axis. The posterior intrinsic back muscles bilaterally isometrically contract for stability to occur. The muscles which contract to produce the dynamic movement is the erector spinae group, containing the posterior iliocostalis, longissimus, and spinalis. This movement allows the shooter to transfer force from the crouch position to the fully extended position at the end of his free throw. Inversely, the muscles which also contract essentially to keep the back dynamically stabilized and ensure the body is in full balance are the transversus spinalis muscles, containing the semispinalis, multifidus, and rotatorius. All this is happening in the frontal coronal plane along the sagittal axis. I will now pass on to Dylan, where he will cover the upper limbs.
The joints that make up the pectoral girdle all move in conjunction with each other to increase the range of motion, allowing for more control over the shot. The sternoclavicular, acromioclavicular, glenohumeral, and the scapulothoracic joints all work together in a process called scapulohumeral rhythm. This allows more flexion and abduction of the glenohumeral joint than if it was moving on its own. As the clavicular head of the pectoralis major contracts concentrically, the distal attachment at the lateral lip of the intertubercular sulcus of the humerus causes flexion at the glenohumeral joint. The deltoid assists in this initial part of the shot, with the concentric contraction of the anterior fibers of the deltoids assisting flexion. The trapezius and latissimus dorsi are contracting eccentrically in the lead up to the shot, acting as antagonists to the pectoralis major. This motion is in the sagittal plane along the coronal axis. In the upper arm, the brachialis is the prime mover in flexion of the humero-ulnar joint. The biceps brachii contracts concentrically as well during this part of the movement, assisting in both flexion at the glenohumeral and the humero-ulnar joints. Both of these movements are happening in the sagittal plane along the coronal axis. Acting antagonistically in the upper arm is the triceps brachii, which is eccentrically contracting at this point in the movement. Once the glenohumeral joint has extended to about 90 degrees, the forearm will extend. The triceps brachii will contract concentrically, while the brachialis and biceps brachii will contract eccentrically, moving the humero-ulnar joint into an extended position. This leads to the final part of the shot, the release. Extensor carpi radialis longus and brevis, as well as extensor carpi ulnaris, are concentrically contracted, while on the anterior side of the arm, flexor carpi radialis and flexor carpi ulnaris are relaxed, waiting to concentrically contract quickly, snapping the wrist anteriorly through the sagittal plane along the coronal axis.